So we're going to start by talking about the parallel functional programming with Java and Android course. I'm going to give you an overview of what we're going to cover in this class. And the first part, we'll talk about sort of the philosophy, what the course is about. I'll give you a summary of the course contents, and I'll also talk about the structure of the lecture material. It's organized in a rather interesting way that may be different from some of the classes you've taken in computer science. So there's a growing need, and this need has been growing for a long time, for software developers like some of you, if you end up going in this direction in the future, who know how to write parallel programs for a range of computing platforms. And this goes all the way from mobile devices, wearables, smartphones, tablets, and so on, up to laptops, which most of you have, desktops, cloud environments, and so on, everything in between. Almost everything these days is parallel enabled. And part of this is driven by advances in software and hardware infrastructure. So for many years, people used to be accustomed to waiting 18 to 24 months for Moore's law to make all the computers twice as fast at about the same cost. For about the past 20 years or so, it hasn't quite gone that way. It used to be up till the sort of mid-2000 time frame that every so often, every 18 to 24 months, computers would pretty much double in speed for various reasons. That really hasn't been the case for a while. They've gotten a little teeny bit faster, but really what's been happening is they're taking advantage of Moore's law, which, by the way, never said things would double in speed. It just said there would be twice as many transistors every 18 to 24 months. That has continued. And what has happened is with all that real estate for doing computation, those transistors are now used to do multi-core processing. So pretty much everything you can imagine has multiple cores now. In fact, it's almost impossible to find a single core computer. My smartphone, my Android phone, has 4 cores on it. I wouldn't be surprised if they don't grow to more, although the battery life is probably the limiting factor there on how many cores you can jam into these mobile devices that are battery driven. But anyway, the point is that there's a lot of advances that have taken place, and so now we have an embarrassment of riches where we need to figure out what to do with all these processor cores. In my experience, having taught this kind of things for decades, just talking about this stuff in the abstract or looking purely at the concepts and the theory is not enough. We need to get deeper into the actual practice of developing and testing and refining parallel programs in various contexts, mobile apps being what we're going to focus on here. So sitting and thinking is not enough. What we really need to be able to do is see by example, and that means I show you lots of examples and you write lots of assignments that show me that you understood the examples, demonstrating how you can make programs easier to read and write, easier to maintain and modify, and more efficient and resilient through the application of certain things. And that's what we're going to be focusing on in this class. One will be time-proven software patterns, which are ways of designing software effectively so you can solve a wide range of problems using a relatively small grab bag of cool approaches, and the embodiment of said patterns in object-oriented and functional design and programming techniques. So we're going to talk a lot about that. I'm going to assume, for sake of argument, that you have a pretty good background in object-oriented programming. I will also assume that you can learn the functional parts very quickly, and I'll tell you more about how to do that in a moment. So this course is going to involve lots of hands-on software development and testing, and we'll talk about that because there's lots of things that have happened in the past 6 to 8 months that make this more fun and more challenging at the same time. So what are we going to do in this course? Well, we're going to be focusing on 4 primary Java parallelism frameworks. And I'm not going to talk about them in detail on this slide because I talk about that in a moment. But we're going to talk about the fork join pool. We're going to talk about parallel streams, which uses the fork join pool. We're going to talk about completable futures, which uses the fork join pool. And then we're going to talk about something called reactive streams, which could use the fork join pool, but doesn't have to. It has its own way of doing parallel processing with its own type of pool. And this particular set of topics is going to assume that you understand Java object-oriented and functional programming features. And I'll talk shortly about where to learn that stuff if you need some refresher. We're also going to be talking about patterns for parallel programming and some patterns for concurrent programming, but largely focusing on parallel programming. And so you'll get a chance to learn about that. There's some great books, many of which I wrote or co-authored, that talk about these topics. So you might want to take a look at this stuff if you take a look at the link at the bottom of the slide. By the way, quick note, all the videos and all the slides will be available on my website. We'll go through my website here in shortly so you can figure out where to go to find more information. I'm going to assume that you either already know or can very, very quickly learn, like in the next week or two, modern Java, not the whole thing, of course, because we're going to cover it throughout the course, but some of the basic building blocks like the functional programming parts, Android, And don't worry, you don't have to become an Android expert. And most importantly for the starters is Git, which is a source code revision control system. And if you take a look here at item number 12 in the course Frequently Asked Questions file, which I strongly encourage you to become familiar with because I'm going to refer to it over and over again throughout the course, this will give you some tips on where you can go to get some of this background if you don't already have it. In particular, I've created a set of videos that will explain Java functional programming features, things like lambda expressions, method references, functional interfaces, that you can watch at your convenience if you need a refresher in those topics. You may or may not have been exposed to those earlier. We're also, for the first time in this course, in its history of being taught for a decade or so, we're going to be applying large language models, which include things like ChatGPT and Bard and Claude and everything else that falls into that category of technologies. In this course, where appropriate. I am a big believer in the importance of large language models and generative AI for the future of our field and for the future of humanity in general. And in fact, if you're interested in hearing some of my views on this as per a couple of months ago, take a look at the link here. This was a keynote talk I gave at a workshop at the National Science Foundation talking about the future of software engineering and AI engineering. And I had lots of fun putting it together. You might want to sort of get a sense of where I see things going. The large language models are a blessing and a curse. They're great because they can make us much more productive when used correctly. They're a curse because sometimes they don't work properly, and you have to learn how to figure out when they're full of BS, when they hallucinate versus when they're helpful. And they're also somewhat of a curse because I realized I had to change all my programming assignments because they were too easy to reverse engineer from the specifications using large language models. So this is the first semester where we're really going to start working with this stuff in practice, with everybody expected to be able to become at least passingly facile with them. And don't worry, it's pretty easy to do that because there's a very, very low barrier to entry with using these technologies. And so we'll talk more about that as the course goes on. So what will the course lecture material be like? Well, we're going to have 4 main modules or 4 main topics. The first one is going to be on the Java fork join framework. And this framework provides a parallel execution engine that's designed to recursively split tasks into smaller and smaller subtasks, process those things in parallel on multiple cores, and then combine the results together to provide a single reduced result. And you'll see that the focus is on optimizing multi-core processor utilization. So we'll talk a lot about how this works, and you'll see that that's really the main goal of the fork join framework, is to make things really use the processor as much as you possibly can. We want to drive it to its limits, as it were. The other technology we'll look at after that is sequential and parallel streams, which is a framework that provides mechanisms to process a pipeline of data in either a single-threaded manner. You can just have one thread, which is a nice way to start to get your program working and debugged. And then you can transparently or almost transparently scale it up by applying parallelism in order to make it run faster, better, cheaper, and so on. So the focus in parallel streams in particular is to scale performance transparently across multiple cores. So in the ideal situation, you split the problem up into smaller chunks, and then as your number of cores increases, your chunks run in parallel faster. And unlike the fork join pool, which requires object-oriented programming knowledge, you don't have to know about functional programming to use that, sequential and parallel streams require you to understand the functional programming aspects of Java. So of course, we will be covering those through various means, some of which you may have to do some self-study, others of which we'll cover in this class. The next topic we're going to cover is the completable futures framework, which enables tasks to execute asynchronously, and it provides a means to combine, chain, and handle task results and exceptions that occur in tasks. Unlike parallel and sequential streams, which is a fairly intuitive, synchronous model, it doesn't take too long to get your head around it once you understand the syntax. The completable futures model is quite a bit different. The patterns are quite different. It's all about asynchronous processing. And so most people don't have a lot of experience with this unless you've done a lot of asynchronous programming with, say, JavaScript and promises and so on. And the focus here is on executing tasks concurrently to leverage multi-core processors for enhanced performance and often, not always, but often non-blocking operations. We'll talk a lot about handling blocking and non-blocking as we go through the course, but that's kind of what completable futures are focusing on. So you try not to block, and it's really, really, really cool. And it's also very, very optimized. It's often the most efficient way of doing things, even though it takes a bit extra work to program it. And then fourth, but by no means last, or I should say last but by no means least, we're going to talk about the reactive streams framework. And this is a newer model which facilitates asynchronous data processing and flow control. And the focus is on parallelism to handle large streams of data efficiently across multiple cores. And this is a very, very interesting model. In fact, in a lot of ways, you can think of reactive streams as kind of the marriage of parallel streams with completable futures, in that you can stream things together, but a lot of the processing is done asynchronously. So these are the four main things we're going to focus on in this course. I teach another course in the spring, which some of you have taken, and that course focuses on other aspects of basically service-oriented architecture and essentially microservice-based ways of building software, and it's also going to focus on even more modern ways of being able to do Java concurrency using things like virtual threads and structured concurrency. We will not cover those topics in this class much at all, other than to mention a few things about virtual threads. If you're interested in those topics, that's for next semester. So each of these modules has got a whole bunch of lessons. There's lots of lessons. Each lesson is composed of parts. Each part is a single lecture, like this one right now. And screencasts of each lesson part and the PDF versions of the slides associated with said lecture part will be uploaded to this website in my CS253 link with the lectures tag in it. So you'll be able to follow along. We'll talk more about that as we get further along. Each part, in turn, is composed of segments, and I don't really know why I mentioned that, but that's just what it is. We will often interactively cover discussion questions at the end of each part, and the purpose of that is twofold. First, it makes the class more interesting than me just droning on and on lecturing. And secondly, it gives you a chance to think about what we've talked about, which can be helpful when preparing for the quizzes. We'll talk more about that in a second. So, speaking of quizzes, there will be bi-weekly quizzes on the material we cover in the lectures and also things related to the programming assignments. We'll talk about that in a second. The first quiz will be next Wednesday, a week from today, on August 30th. And quizzes will be in class for several reasons. And all quizzes, since they're in class, may be sort of obvious. They're closed book, closed note, closed internet, closed ChatGPT, closed Bard, closed Claude, closed everything. You have to be open mind, but closed everything else. We're doing them in class for one very important reason. I've been doing them online in Brightspace ever since the pandemic broke out a number of years ago. But I discovered that I was not learning anybody's names. And so one of the great things about doing them in class is I can pass out the quizzes to you at the end of when you get them back, and then I can learn everybody's names, which is really great because I've really missed that. We will try to give the quizzes back at the start of the next class, so quizzes are always on Wednesday, and then we'll give them back the following Monday, which is one of the benefits of having a reasonable sized class. How do you study for quizzes, you may ask? Well, I recommend you study for quizzes by reviewing the PDF versions of the slides and watching the screencast if you need to refresh that. One of the great things about uploading stuff to YouTube is you can go back and either watch it faster if you want to skip over things that you know, or if you think I talk too fast, which I usually do, you can slow it down. So you can pick the pace at which you want to revisit this stuff. So that's how you should study for the quizzes. And there'll be all kinds of screencasts and videos we'll talk about in a second that will help you prepare for that. Now, very important thing. Class attendance is mandatory even though everything's up on the web. Why is that, you may ask? That's because in my experience, when people don't show up in class and when they don't pay attention, then they show up later and say, I don't know what's going on. And so by showing up, you can be involved. So if you don't attend the next class, in other words, if I hand back the quizzes and there's a pile of them that were not picked up, then you lose 50% of your quiz grade. So incentive to show up after the quiz the next time. And this is all summarized here at this link on my website. Likewise, we typically do the quizzes the last half hour of class. So if you just show up at whatever that would be, 9:25, you also get penalized. So show up early, pay attention, participate. We'll talk more about that in a second. There may or may not be a cumulative final exam that covers all the lectures. And if we do have one, and I'll talk about why we might not have one, it'll focus on the last thing that we covered since the last quiz. If we have a final exam, I looked it up, it'll be held from 9 a.m. to noon on Saturday, December 16th in class. Now, the reason we don't always have a final exam is sometimes the final programming assignment tends to slip a little bit in terms of when the final version's due, and we'll talk more about those things in the next part of this lesson. And if that happens, I don't want people to have to both study for an exam during exam week and also finish up whatever they need to do to get their assignment turned in. So I don't always know how long it's going to take for people to do the assignments, so that's why it's a question mark. So we'll discover that as we get further along. So bottom line, don't book your flight out on December 15th yet. We'll know later when you can do that. So that's the end of the overview of the first part of this 4-part introductory section.